So here's the learning target today. We want to learn to evaluate a function at a given point. And we're going to look at several ways functions may be defined and talk about how to evaluate those functions at different elements in the domain. So our first function here is defined as a table, and these are very straightforward. If we look at our function here, f of 1 corresponds to 7. That is, we put 1 into our function f, and it has an output of 7. We put 2 into our function f, and it has an output of 13. We put 3 into our function f, and it has an output of negative 11. We put a 5 into our function f, and it has an output of pi. So very straightforward. Tables are very straightforward. I think everyone should get that. Our next example is we have a function defined with a formula. So g of x equals x squared. G explicitly says whatever you put in me, square it. So if you put a 3 into g, you must square the 3. So 3 squared equals 9. So g of 3 equals 9. If you put a negative 1/2 into g, you must square it. So negative 1/2 squared, that's going to be a positive 1/4. This is a little more abstract. It gives students fits, but if we think about it explicitly is what the instructions that G gives us. G says whatever you put in me, square it. So we put 1 plus t into G. So 1 plus t squared. Let's write that out as 1 plus t times 1 plus t. A lot of you students want to jump right to this equals 1 plus t squared, and it's incorrect. So make sure you use the distributive property here to get t squared plus 2t plus 1. Work that out. Pause the video and make sure you can do that. Again, here been just a hair more abstract. We're putting x plus 5, the sum of x plus 5 divided by pi into g. But it's still the same thing. Whatever you put into g, you must square it. That is how g is defined. So x plus 5 divided by pi squared is going to be x squared plus 10x plus 25 divided by pi squared again. Make sure, stop this video and make sure that you can work out that multiplication. The final example we're going to do today is going to be what's called a piecewise defined function. It's called piecewise because it's defined differently on different pieces of its domain. For its domain, when x is less than 0, we do this to it. We do 3 times x. When x equals 0, we just have the constant function square root of 2. And for any x bigger than 0, we have x squared plus 7. So here is the when x equals 0, we get the constant function square root of 2. If we look at when x is a negative 1, so h of negative 1, we go up here and look, and negative 1 is not bigger than 0, it doesn't equal 0, but it is indeed less than 0. So we do this to it, 3 times negative 1. It's going to give me a negative 3, so h of negative 1 is a negative 3. Negative 10, we're plugging a negative 10 into h, so x equals a negative 10. So is a negative 10 bigger than 0? Nope, it doesn't equal 0, but it is less than 0. So again, we do 3 times negative 10, and it should give me a negative 30. And what if we plug in a positive 10? So x equals a positive 10. Is x bigger than 0? Yes. It's not equal to 0, it's not less than 0, but it is bigger than 0. So we do this to it, x squared plus 7. So it's going to be 10 squared plus 7, and that should equal 107. Lastly here, let's plug x equals 20 into h. And again, if we look up here, we see that 20 is not less than 0, it's not equal to 0, but it is bigger than 0. So we do x squared plus 7. And we get 20 squared plus 7, and we get 407. And that will conclude this video. Thank you.